Okay, so now that we know what the auxiliary method is and where it comes from, we're going to do a few examples. Now there are two main reasons why we want to use this method. One might be we're asked to sketch a function that has sine and cosine. Really hard for us to do without technology, so if we can use the auxiliary method, we can write it with only sine or only cosine. And the same for the second time that we might want to use it is if we are trying to solve an equation that has sine and cosine. And we can use the auxiliary method to do the same thing to help us to solve it. So let's get started.
Okay, first example. We are asked to write sine x minus root 3 cos x in the form r sine x minus alpha. So we understand where the auxiliary method comes from, so we can just use the result. So r is the square root of, coefficient of sine is 1, coefficient of cosine's root 3, but I know it's going to get squared, so I don't really care about it being negative. 1 squared is 1, root 3 squared is 3, so this is root 4, which is 2. Okay, so r is 2, and then tan alpha I get from b over a, so root 3 over 1. And if I want to solve alpha, it is inverse tan of root 3. That's an exact value that we know, so that is pi on 3. So sine x minus root 3 cos x is equal to 2 sine x minus pi on 3. Okay, so for the next part of this question, we might be asked to sketch sine x minus root 3 cos x, and let's do that from 0 to 2 pi.
So now if we get asked to sketch y equals sine x minus square root 3 cos x, then what we want to do is use the auxiliary method. We can write that just in terms of sine, and that makes it a lot easier for us to sketch. So we just showed previously that that is 2 sine bracket x minus pi on 3 close bracket. So instead of sketching the first one, we're going to sketch that second option because it's just in sine. So we want to think about our principal axis. I'm cheating a little bit here using Desmos. Principal axis has not been shifted up or down, so it's y equals 0. So maybe you can see that faint green line on our x-axis. And this graph here has been shifted pi on 3 units to the right. So it's sine, I'm starting it on the principal axis. So pi on 3, 0 is on there. And that's going to be, this here is going to be my start point. And then my period for this one is 2 pi. So I want to keep adding quarters to go up, then back to the principal axis, then down, then back to the principal axis, and I want to get one full cycle. So if my period's 2 pi, divide that by 4 is pi on 2. So I'm going to keep adding pi on 2. So pi on 2, and then it's going to go up, and this one has an amplitude of 2. So I'm going to go up to 2, add another pi on 2, and back to the principal axis, add another pi on 2, and now I'm at negative 2, and then add another pi on 2 and back at 0, but we can't see that because I'm just sketching from 0 to 2 pi. Alright, so they're going to be my points, and I'm just going to want that to join up. So let's have a look. Okay, it looks like that. And I also got the original one here, and let's just see that that's the same. So I'm going to turn that one on and turn that off, and you can see that they're actually the same function.
Okay, and following on this example, maybe we get asked to solve sine x minus root 3 cos x equals 1. Now that would be really hard for us to do without technology, so we use the auxiliary method. We know that this is equal to 2 sine x minus pi on 3 equals 1. So this is now much easier for us to solve, and we'll go about that. So divide by 2, sine x minus pi on 3 is a half, inverse sine, When is sine positive a half? Well, that's the first and second quadrant, and for 1/2 is pi on 6. So my two solutions are pi on 6 and 5 pi on 6. But I need to add pi on 3, or in other words, 2 pi on 6. So my final answers are 1 pi on 6 plus 2 pi on 6 is 3 pi on 6, or pi on 2, and 5 pi on 6 plus 2 pi on 6 is 7 pi on 6. Okay, second example we are going to do today. So we're going to write 3 cos x minus 2 sine x in the form r cos x plus alpha. And we're going to use one in degrees just to make it a little bit different. Alright, so let's start by finding our r value. So r will be square root of 3 squared plus 2 squared. 3 squared is 9, 2 squared is 4, so this is root 13. Okay. Now we need to find alpha. That'll be tan alpha is b over a. Now b this time, because we're writing it in the form of cos, then the coefficient of cos is our a and the coefficient of sine is our b. So it's going to be 2 over 3. So alpha is arc tan 2 over 3. So also to change this one up a little bit, I don't know when tan is 2 over 3. That's not an exact value that we need to remember, but that is, using our calculator, want this one in degrees, 33.6900 dot 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 dot, so approximately 33.7 degrees. So finally, 3 cos x minus 2 sine x is equal to root 13 cos bracket x plus 33.7. Okay, so next part, let's sketch this function from 0 to 360 degrees.
Okay, so now sketching the function y equals 3 cos x minus 2 sine x from 0 to 360 degrees. We need to make sure our mode is in degrees for this one. And we just showed previously that that is the same as square root of 13 cos bracket x plus 33.7 degrees, close bracket. So let's think about our principal axis. There is no shift up or down, so it's still going to be at 0. I'm going to put that there. And then the plus 33.7 is going to shift this function to the left 33.7 degrees. So that's going to be my start point. Now, because it's a cosine, it's going to start at the top, which is going to be square root of 13, because that is my amplitude. Now we can't see that point because our domain is from 0 to 360, but this is how I would do it by hand. I just make sure I wouldn't include that part. Alright, now my period for this cosine function is 360 degrees, so a quarter of that is 90, so I'm going to add 90 to the next point, add another 90, so that's 180, add again 270, and the last one 360. Okay, so I'm just adding, splitting it into quarters and adding those, and it's going to start up, back to the principal axis, which is 0, then down, which is going to be minus square root of 13, then back to the principal axis, and then up, which is going to be square root 13. Okay, so let's have a look at our points here. Okay, so you can see it's here, and then there's a point up here. That should have been negative, there we go, the point up there. So let's have a look. If I was doing this by hand, I'll just join those points up with a nice cosine wave, and it looks like that. Okay, and we can see again that our what we did in the first part is actually the same. So if we turn that one off, and you can see it goes through there.
Okay, final part of our question here is let's solve 3 cos x minus 2 sine x equal to -3. So we're going to use our auxiliary method. We've already done that. We know that the left hand side is the same as root 13 cosine x plus 33.7, and I want that to equal -3. Okay, so cosine is x plus 33.7 negative 3 over root 13. And now I do inverse cosine. Negative root 3 over 13 is not a number that I'm expected to know, so I can use my calculator. But when is cosine negative? Cosine is negative in the second and third quadrants. So if I use my calculator, I get 146.3099. Okay, and then so the difference between 180 and this is the angle that I want to add to 180, which is 213.6900. Dot 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 dot. Okay, so second quadrant and third quadrant, but I haven't quite finished yet because I need to subtract 33.7 from each of my solutions. So x is 112.609 dot 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 and 179.9900 dot 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 dot, and so approximately 112.61 and 179.99.
Okay, so that was just a couple of examples where we can use the auxiliary method. So what we're looking for is an equation that has sine and cosine in it. Not always the case though. We might use our t formulas, or we might make some other substitutions. We might be able to get sine over cosine to get tan. So it's not always the case, but just remember that it's in your toolkit. Now go out on a joke. Knock knock. Yeah, that's not going to work, is it? I'll see myself out.